Welcome Spartans, you are watching my YouTube channel Breathing Physics and I am your physics professor PD sir. Today I have come with new part of this vector series, part number 6, that is vector addition by parallelogram. So in a previous part we have learned vector addition by triangle law, and in this lecture we are going to see vector addition by parallelogram law. So before going to start this video, I want to announce some names, and they are Pratik Teli, Rachna Kamte, Shweta Guru, Swapnil Narute, and Snehal Patil. Okay, these are the names. These students have given the answer of previous quiz very early as well as with the proper explanation. That's why I have announced their name. Okay, in this part we have quiz 2 at the end of our lecture. So stay tuned. Okay, so we have definition of our parallelogram law here. This is our definition. In this definition, if two vectors of same type, first line, if two vectors of same type means force, velocity, or displacement. That means the vectors we are going to add should be of same type. That's it. Starting from the same point. This is very important thing. They should be start from same point. That means, see here, if first vector is starting like this from this point, then second vector should be start from this point. Okay, that means both the vectors should start from same point. Okay, start from same point, are represented in a magnitude and direction. So it is a vector quantity. Basically it has to be represented in a magnitude and direction, there is no doubt, by the two adjacent sides of parallelogram. So in a previous lecture we have said by the two sides of triangle, and here we are saying that by the two adjacent sides of parallelogram. This word is very important, adjacent side. That means one vector should be like this and second vector should be like this, and both should be start from same point like this. So two adjacent sides of parallelogram, then their resultant, so resultant of that two vectors which are be represented by the adjacent side of parallelogram is given in a magnitude and direction. Basically resultant vector is also vector, so that magnitude and direction by the diagonal of the parallelogram starting from the same point. Okay, so the common thing here is the same point. Three of the vectors should be start from same point, so no confusion here. Always we have starting point is a common. That means let's say this is one vector, this is one vector, these two vectors we have to add. So like parallelogram structure, and this should be diagonal. This is the resultant. Let's say this is A bar, this is a B bar. Okay, this is A bar, this is B bar. Then this will be resultant, which is diagonal, and three of the vector are starting from सेम पॉइंट. इसका मतलब कि अगर किसी भी दो वेक्टर को हम पैरेललोग्राम के एडजेसेंट साइड से दिखाते हैं, इंडिकेट करते हैं, तो उसका रिजल्टेंट जो रहेगा वो पैरेललोग्राम का डायगोनल रहेगा. और ये जो ऐड करने वाले जो दो वेक्टर्स है एज वेल एज रिजल्टेंट वेक्टर, ये तीनों वेक्टर सेम पॉइंट से स्टार्ट होने चाहिए, सेम पॉइंट से स्टार्ट होने चाहिए. ओके, वी विल लर्न दिस इन अ डेप्थ. जस्ट नोट डाउन दिस डेफिनेशन. ओके, नोट डाउन. लेट्स we have a vector here and another vector like this. Let's say this point is m, this point let's n, and we make one parallelogram structure here, parallelogram structure m n p. Let's say this is a q. So this is the diagonal, am I right? This is the diagonal which is a resultant vector. Okay, let's say this vector is a A bar and this vector is a B bar, and three of the vectors, both these vectors are starting from same point. That means tail and head. So according to law of parallelogram, resultant vector should be start from same point. Okay, and it should be the diagonal of parallelogram structure. So it is a diagonal. Okay, like this. That means we have to add these vectors as we are represented these two vectors by the adjacent sides. This word is very important, adjacent. It's not like that A bar is here and B bar is here and then you are going to add by parallelogram. No, it's not that. We have to add these two vector when we indicate these two vector by adjacent sides of parallelogram. At that time, resultant vector will be diagonal of parallelogram. Okay. So next step is that in a previous part 2 we have find out the magnitude of this resultant vector as well as a direction also. So in this law also we are going to find out what will be the magnitude of this resultant vector as well as its direction. Okay, so we will see that. So let's find out what will be the magnitude of resultant vector. Here I have make one structure which is a parallelogram. Let's say this vector is A bar. You can take A bar to this side or this side, it doesn't matter. We have to this vector as A bar and magnitude of this vector is equal to A. Similarly, magnitude of B vector is a B and magnitude of resultant vector is a R. So if this is the B, if its magnitude is B, then definitely this magnitude will also equal to B. Okay. So I will make some changes like this. Okay. So it will be 90 degree. Let's say this point is a S. This point is a S. And in a previous lecture you know that we have took this as a theta. So if this is theta, then definitely this angle will be also equal to theta. Okay, am I right? This angle also equal to theta. So if this is theta, then what will be this side? This side we will use sine angle. So sine theta here, sine theta is equal to opposite side divided by hypo. So B. So PS will be equal to B sin theta. B sin theta. So this side will become B sin theta. Similarly here if you use cos theta, so cos theta will be equal to adjacent side NS divided by hypotenuse, which is a B. So NS is equal to B cos theta. So NS will be equal to B cos theta. That's it. So we have got the length of this side as well as this side. So now we will use Pythagoras प्रमेय as in a previous lecture 2 we have used same concept. By Pythagoras प्रमेय in MPS in a triangle MPS, square of this side, that means R square will be equal to square of this side equal to square of this side plus square of this side. That means PS whole square plus MS whole square. MS whole square. So PS has value of B sin theta. So B sin theta whole square plus MS is nothing but MN plus NS. That means A plus B cos theta. So A plus B cos theta whole square, bracket square. Here this square is bracket square. So that is equal to B square sin square theta plus A plus B cos theta whole square will be like A square plus 2AB plus B square, that kind of thing. So A square plus B square cos square theta plus 2AB cos theta. 2AB cos theta. So R square. So R square will be equal to, here we have B square sin square theta, B square cos square theta. We take B square as a common, in bracket sin square theta plus cos square theta. Sin square theta plus cos square theta. Okay. After that A square. So after that A square plus 2AB cos theta. 2AB cos theta. Okay. So come here. So R square. Let it go. Just note it down. Okay. So you know that mathematical identity sin square theta plus cos square theta is equal to 1. So it is equal to B square only. B square plus it becomes 1. B square plus A square plus 2AB cos theta. So that is equal to a square plus b square plus 2ab cos theta. It's nothing but r square. So r is equal to under root a square plus b square plus 2ab cos theta. So this is the magnitude of resultant vector, okay, which is we have shown here by diagonal of parallelogram when we represent two vectors as adjacent sides of parallelogram. If we put here in a previous lecture too, we have seen two cases that theta is equal to 0 degree and theta is equal to 180 degree. So if you put here theta is equal to 0 degree, cos 0 become 1 and whole structure becomes a plus b only, which is maximum resultant. And when we put theta as a pi or theta as 180 degree, then it becomes r is equal to a minus b, which is a minimum resultant. You know that both the cases. So this is the magnitude of resultant vector, which is similar to the we have seen a triangle law. In a triangle law also, magnitude of resultant vector is similar to this square root a square plus b square 2ab cos theta. So next step is how to find direction of resultant vector, because in a triangle law there was a resultant vector was we always represented in opposite order, but here resultant vector is starting from same point. So we have to find what is the direction of resultant vector. Okay, so note it down. In next point we will cover direction of resultant vector. Okay, to find direction of r bar, we know that how to find direction. We have to we have to tell at what angle from this vector, our resultant vector is there. So our resultant vector, let's say at angle beta, this is a beta, don't forget this is a beta, not a b. So at angle of beta from this vector we have our resultant vector. So its direction is at a angle beta from a. So let's take tan beta. To explain the direction of resultant vector, we just have to told what is the angle. So tan beta is equal to opposite side, which is ps, in a triangle ps divided by adjacent side ms. So ps is nothing but b sin theta divided by ms is nothing but mn plus ns, that is a plus b cos theta, this is tan beta, which is nothing but direction which is used to say or told direction of your resultant vector. Okay, so these are two formulas, magnitude of resultant vector and direction of resultant vector. Now we will see some example on this. Okay, so note it down. Okay, we will see one example on parallelogram law. So here is the example: two forces whose magnitude are in the ratio 3:5. So two forces are there, let's say they are F1 and F2, and their ratio of magnitude is 3:5. That means F1 divided by F2 is equal to 3 divided by 5. Gives a resultant of 28 Newton. So it gives the resultant of 28 Newton are represented by two sides of parallelogram, and that sides definitely will be adjacent sides. Find the magnitude of each force. So we have to find F1 as well as F2, their magnitude, by considering theta is equal to 62 degree. Okay, just note it down the example. Let F1 and F2 be two forces, then definitely F1 divided by F2 is given as 3:5, which will gives us F2 is equal to 5F1 divided by 3. This is equation 1. So we know that resultant vector has a formula of a square plus b square plus 2ab cos theta. So that will be equal to a means first vector, b means second vector, their magnitude. So similarly here f1 square plus f2 square plus 2f1 f2 cos theta. That's it. Okay, so it will become in a bracket square root f1 square as it is plus f2 has value of 5f1 by 3. So 5f1 by 3 whole square plus twice f1 into f2 has value of 5f1 by 3 into cos theta. So theta given as a 60 degree, we will put here 60 degree, and you know that cos 60 has value of 1 by 2. So 2 get cancelled here, so that will be equal to f1 square plus 5 square 25 f1 square divided by 3 square 9 plus f1 square 5 by 3 f1 square. So that will be equal to 9 f1 square plus 20 f1 square will be how much? 34 f1 square divided by 9. 34 here. 9 f1 square plus 20 f1 square, 34 f1 square divided by 9 plus 5 by 3 f1 square. Okay, so it's very easy, just mathematics is there, just note it down. So let's make this base equal. So 34 by 9 f1 square plus, let's multiply this by 3, so 15, similarly 3, 9 f1 square. We just multiply here by 3 as well as here by 3, so it won't affect. Okay, so 34 f1 square plus 15 f1 square divided by 9, which is equal to 34 plus 15 is nothing but 49 f1 square divided by 9. So it is nothing but 7 f1 square will come out as only f1 and divided by 9 comes out as a 3. So this is 28 is equal to 7 f1 divided by 3. Therefore f1, let's say, therefore f1 will be equal to 28 multiplied by 3 divided by 7. From this comes, so that is equal to 7 for 28, so 12 Newton. So f1 will be equal to 12 Newton. Okay, and if we use here, as we know that f1 divided by f2 is given as 3 by 5. Okay, 3 by 5. So that f2 will be equal to 5 f1 by 3. So 5 multiplied by f1 as value of 12 Newton. 12 divided by 3 equals 12. So f2 is equal to 20 Newton. This is the answer. So we have find out both the forces, f1 is a 12 Newton and f2 is a 20 Newton. Similarly, they have given as a resultant of 28 Newton. So we can analyze that maximum result will be f1 plus f2, which is 20 plus 12, that will be 32. So up to 32 Newton, if they have given resultant, that means data is appropriate, there is no problem. But if above 32 they have given, then definitely in a question data definitely will be inappropriate. Okay, just note it down. Okay, so the part quiz, the question is the maximum and minimum resultant. You know that maximum resultant and minimum resultant concept definitely. Okay, so of two forces acting at a point is a 10 Newton and 6 Newton. So maximum resultant is given as well as minimum resultant also given 6 Newton respectively. If each force is increased by 3 Newton. Okay, so initially these are given for the maximum resultant as well as minimum resultant, and after that they have increased each vector by 3 Newton. So let's say initial magnitude will be f1, then next magnitude f2 is f1 plus 3. Okay, 3 Newton. The resultant of new forces acting at a point at an angle of 90 degrees. So theta is also given, theta is 90 degree given. The clue is like that, you have to take initial two vectors, let's say they are f1 and f2. For that f1 and f2, maximum and minimum resultant is given as 10 and 6, and after that we have add f1 plus 3, f2 plus 3. At that time, what will be the resultant if theta is 90 degree? Okay, so this is today's quiz, and guys, give answer in a comment box. We are going to give answer properly. and early I am going to announce their name as well. So I hope today's lecture will be interesting for you as well as you enjoyed it a lot. I hope that, and in the next lecture I will come with some new concept as well. So if you like this lecture, please like, comment, subscribe, press the bell icon as well as share to them who need this lecture. So thank you for listening and be safe. Take care.